Hello everyone, in this video we will see about magnetic declination and also different terms associated with magnetic declination like agonic and isogonic line, diurnal and other variations in declination, and also we will see about needle dip. We will also be solving some problems which often come in exams based on magnetic declination. So what is this magnetic declination? In the last video we saw about true bearing and magnetic bearing. In true bearing, the reference line is true meridian, which is fixed and which is the north-south line, and it does not vary with time, it is constant. Whereas in magnetic meridian, it is what a freely floating compass shows. Magnetic meridian I am writing like this. So here magnetic meridian varies with time. So the difference between true meridian and magnetic meridian is magnetic declination. Suppose we refer to magnetic declination as theta equal to true meridian minus magnetic meridian. This is the reference point. If bearing is given, it is true bearing minus magnetic bearing. So let us say this is the true meridian and magnetic meridian goes like this. So this theta is magnetic declination. Here theta is towards the east, so it is positive. Suppose if magnetic meridian is towards the west, it will be negative. So magnetic declination is true meridian minus magnetic meridian. If it is towards the east, theta is positive, and if it is towards the west, theta is negative. Horizontal angle between true meridian and magnetic meridian is magnetic declination. Now let us see what is agonic line and isogonic line. Agonic line is lines joining points of zero declination. There will be points where magnetic meridian and true meridian will be equal. So the lines joining those points of zero declination is agonic line. And isogonic line is lines joining points of equal declination. If suppose at one point the declination is 3 degrees and at other point also it is 3 degrees. So the line joining points of equal declination is isogonic line. It is also worthwhile to note that true meridian at noon, when the sun is at the top, will be 0 degrees or 180 degrees depending on which hemisphere it is. It will be useful in solving problems. Now let us see an example to find out magnetic declination. They have given that south 34 degree west. This is the magnetic bearing. That is with respect to the magnetic meridian, the angle is south 34 degree west, and they have given the declination as 8 degree 30 minutes. 30 minutes, actually there are 60 minutes in a degree. 1 degree there are 60 minutes. So here 8 degree 30 minutes is 8.5 degrees or 8 degree 30 minutes west. So we have seen that west is negative and east is positive. So true meridian minus magnetic meridian is declination. So here they have asked for true bearing. First we have to convert the south 34 degree west to WCB terms, whole circle bearing terms. So we know here it is south. Southwest means it lies in this quadrant, it is 34 degrees. So the whole circle bearing, when you measure clockwise from north, will be this is 90, this is 90, 180 plus 34. Whole circle bearing will be 180 plus 34 degrees, which is 214 degrees. So true meridian minus 214 degree equal to minus because it is in west, 8 degree and 30 minutes. So the true bearing will be 214 minus 8 degree 30 minutes, which is equal to 205 degree 30 minutes. Now we have to again convert this into reduced bearing to know the answer. So it is 205, it is greater than 180, 90, 180 and 205. So whole circle bearing will be 205 degree and 30 minutes. So you want to know the reduced bearing. It is in southwest. So this you want to know. This is nothing but 205 degree 30 minutes minus 180 degree. It will be south 25 degree 30 minutes and west. So this is the true bearing of this magnetic bearing with declination given. Let us solve one more question which came in engineering services exam. So here they have given magnetic bearing as north 57 degree east. So when you draw into whole circle bearing terms, this is north and this is east, it will come in this quadrant only. So whole circle bearing is also 57 degrees. Now they have given the declination as 2 degree east, which is positive 2 degrees, east is positive. Now they are asking if the magnetic declination has become 4 degree west, how much will PQ change? So first let us find out what is the true bearing when it was in the old map. True bearing never changes with time, so you can compare with between old map and new map. So true bearing minus magnetic bearing equal to declination. So here you know that magnetic bearing is 57 degree and this is 2 degrees positive because it is in east. So true bearing equal to 57 plus 2 equal to 59 degrees. Now they are telling that the magnetic declination has become 4 degrees west. So what will be the magnetic bearing of the line? Now we know the true bearing of the line 59 degree minus magnetic bearing equal to declination. It is minus 4 degree because it is in west. So magnetic bearing will be 59 plus 4 equal to 63 degree in WCB terms. So 63 lies within 90 only. So in reduced bearing terms also it will be north 63 degree east. So the answer is option B. I hope you guys are clear with magnetic declination now. Now let us move to the next topic, which is variations in declination. We know that magnetic meridian is not fixed, it changes with time. So what are the different variations possible? So diurnal variation, secular variation, annual variation and irregular variation. Diurnal variation means it varies daily. It depends on the locality, season and time. The variation is more in day, summer season it is more variation, and towards day more variation than in night, and also towards the magnetic poles, that is north and south pole, the variation is very high. And annual variation is yearly variation. Every year it will change by some small amount of degrees. And secular variation is like every 250 years approximately, it follows a cycle like a sine curve. The variation keeps on changing. Like if you take one point A, it would have been 10 degrees declination in 2000 year, but it would have been 8 degrees declination in 1750. So this is secular variation. Irregular variation is it does not follow any pattern. Suddenly if an earthquake comes or any other strong influence comes, the declination will vary. Now let us see what is needle dip. Needle dip is the angle of magnetic lines of force with the Earth's surface. Earth itself is a big magnet. So if you have the north and south like this, the magnetic lines of force will be like this. So the angle which the magnetic lines of force make with the Earth's surface is called needle dip. It is called needle dip because when a freely floating compass is there, the magnetic needle will have an inclination with the horizontal. That is why it is called needle dip. So at the equator, the dip is 0, and at the poles, dip is 90 degree. If you see at the poles, the force is perpendicular to the reference line. So that is why dip is 90 degrees at the poles. Thank you guys for watching the video. To continue to watch more videos, please subscribe to our channel.